ما مشتاقانه در انتظار شنیدن این هستیم و چند تا سوال از قبل اومده که حالا اینا رو بعد از فرمایشات شما اگه جواباش داده نشده باشه اونا رو مطرح خواهم کرد.
من حدود 33 تا اسلاید دارم، 2 تاشون ویدیو هست، بقیه اسلاید هست. حدس میزنم که یه چیزی نزدیک 40 دقیقه یا زیر 40 دقیقه اینا عرضه بشه.
من خیلی شرمنده هستم صدای شما رو قطع میکنم آقای دکتر، خیلی معذرت میخوام. جناب دکتر مهاجر، شما لطف بفرمایید از هاست بودن استعفا بفرمایید تا ما بتونیم برنامه رو تنظیم کنیم. الان مشکلات فنی
نه من کو هستم.
بله از همونجا لطفا شما ریلینگویش کنید، آزاد کنید اونو.
عرض کنم که قراره که جلسه رو آقای دکتر حسین نجات شروع بکنن.
ببینید
و بعدا
بله آقای عزیزی و اینا الان همه میخوان که این کارا رو انجام بدن، متاسفانه دست و بال همه بسته است. شما اگه اون آزاد بفرمایید انشالله درست میشه.
بله اجازه بده.
معذرت میخوام آقای دکتر نادری شما رو صداتون رو قطع کردم.
نه خواهش میکنم که جالب کودتا شد.
آره این مسئله فنی پیش آمده، الان هست کانون اصلا دسترسی به هیچی نداره. یه دور دیگه باید
بله اجازه بدید. پارتیسیپر هست من برم اونجا.
شما هست
میگم آقای دکتر حسین نژادم کو-هستم.
من آقای دکتر واقعیتش اینه که نیازی نیست. من یه صحبتی دارم، بیشتر باید خود آقای دکتر نادری باشن و یکی از خود جناب عالی هم به نظرم میرسه خب نیازی به هست بودن نداشته باشه. شما فقط باید اون وقت باشه که اون صحبت رو بکنید، تو میکروفون رو در واقع بچرخونید.
بله خب البته من بعد ضمن معرفی ایشون یه چند سوال از قبل همونطور که عرض کردم اونا رو مطرح بکنم.
درست میفرمایید.
این است که من فکر کنم چند نفر میتونن کو-هست باشن.
جناب مهاجر شما همچنان هست هستید، لطفاً اونو آزاد بفرمایید. یه لحظه
اجازه بده من پیداش کنم.
درود بر شما.
روی اسم خودتون ملاحظه بفرمایید که یه جایی هست که میتونید هست رو پس بدید.
با سلام خدمت همه عزیزان.
درود بر شما، خوش
آمدید. درود.
فیروز جان منم از این فرصت استفاده میکنم، محبوب هستم.
سلام محبوب جان، چطوری؟ خوبی؟
مرسی، خوش آمدید، خوشحالم میبینمتون.
Good to see you. این روزها فقط در طریق زوم میشه مثل این.
دقیقاً همینطوره، ولی اینم مغتنم باید غنیمت باید شد، چون فرصت‌های زیادی رو فراهم کرده همه از هر جای دنیا با هم وصل بشه.
دقیقاً.
سلام عرض میکنم خدمت همه دوستان عزیز.
درود بر شما آقای
درود به همگی.
سلام عرض میکنم به همه.
با سلام خدمت دوستان، من کامیاب هستم.
منم همایون مومنی هستم، خیلی خوشحالم از دیدار روی ماهتون.
با درود
زمانی هستم، سلام عرض میکنم خدمت همگی.
زاهدی هستم، سلام عرض میکنم.
من سلام عرض میکنم خدمت همه دوستان.
سلام عرض میکنم خدمت همه دوستان.
سلام خدمت همگی.
درود به همگی دوستان.
درود بر شما همگی، خوش آمدید و شرمنده که چند دقیقه منتظر بودید تا ادمیت بشید. ما مشکل فنی پیدا کردیم که اینو داریم حلش میکنیم ان شاءالله.
بنده هم خدمت همه عزیزان سلام عرض میکنم.
درود بر شما، خیلی خوش آمدید.
ما تو الان بالای 110 نفر الان هستیم.
ریاحی هستم، سلام عرض کردم خدمت همه دوستان.
دکتر حسین نژاد شروع بفرمایید.
بله.
بعد برنامه رو بریم جلو، چون من فکر کنم مسئله الان نیست. شما هر چی سعی می‌کنم
دیگه الان شروع کنیم. آقای خداونده حل شد مشکل فنی شما؟
نه خیر، تا آقای دکتر هست و پس ندن.
درست شد. ببخشید. بله من الان هستم و دارم ادمیت میکنم.
بله حل شد مثلا.
حل شد.
بله مرسی.
خب 113 نفر تا الان اومدن. من با اجازهتون شروع میکنم یه مقدمه خیلی کوچولو، بعد فرمونم دست جناب آقای دکتر مهاجر. دوستان و همراهان گرامی، برای من کمال افتخاره که امروز بعد از 4 سال حضور مستمر در هیئت مدیره کانون مهندس، افتتاح کننده آخرین سری از سخنرانی‌های ماهیانه کانون در دوره 33 هیئت مدیره کانون باشم. کانون که میدونیم بیش از 33 ساله که با قدرت تونسته از تمام این تندبادها به قول معروف جان به در کنه و بمونه و واقعیتش اینه که با کمک دوستانی که بوده با قدرت و با حمایت تونسته در واقع این کامیونیتی توی کامیونیتی ایرانی ریشه‌ای بدونه و باعث این بشه که به نیوکامرا کمک بکنه، یک ارتباط خیلی خوب نتورکینگ ایجاد کنه که باعث بشه که اینجا جامعه ما بیشتر در واقع همدیگر را یاری کنه. مهمان ویژه ما که احتیاجی به معرفی ندارد، ایشون چهره بسیار بسیار شناخته شده و افتخار ایران و ایرانی جناب آقای دکتر فیروز نادریه که در واقع دانشمند فضایی که با سوابق بسیار درخشانی و کار در ناسا برای همه ما تقریبا شناخته شده هستند. حالا برای معرفی گوشی از خدمات ایشون در واقع کاری که برای جامعه جهانی کردن از آقای دکتر ارسلان مهاجر که خود ایشون هم فرد بسیار شناخته شده و سوابق بسیار خوبی در دانشگاه‌های اینجا دارن، خواهش کردیم که در واقع یک گوشه‌ای از سوابق کاری آقای دکتر فیروز نادری رو برای ما در واقع اعلام کنه. ضمناً برای اینکه در واقع بعضی شرکت کنندگان ما با زبان فارسی احتمالاً آشنایی ندارن، آقای مهاجر فکر میکنم که معرفیشون انگلیسی باشه و مدت سخنرانی همونطور که آقای نادری فرمودن بین 30 تا 40 دقیقه، فرمودن 33 تا اسلاید دارم و 2 تا در واقع ویدیو و بعد از اون ما بحث در واقع پرسش و پاسخ رو داریم. منتها در رابطه با پرسش پاسخ ایشون در واقع سخنران خواستن که دوستان اگر سوالی چیزی دارن سوالها رو به صورت مکتوب در همین چت اعلام بفرمایند، بعد سوالا رو بررسی ما میکنیم، اونایی که تکراری باشن در واقع با هم دیگه ادغام میکنیم، اونایی که تکراری نباشن در صورتی که زمان اجازه بده در واقع پاسخ داده بشه. فکر میکنم یه تعداد سوال هم چون قبلا ایشون خواسته بودن که مکتوب نوشته بشه، سوالایی هست که آقای دکتر مهاجر اینا رو یادداشت کردن و ایشون در واقع اعلام دادن. آقای دکتر مهاجر من خواهش میکنم از شما که شروع بفرمایید.
Thank you very much. Do you have my voice? Do you have my voice? Okay, ladies and gentlemen, I'm delighted welcoming all to our joint session with Mohandas and our colleagues at University of Toronto and academicians from Ryerson, McMaster, and York universities. I am especially grateful that Dr. Firouz Naderi has kindly accepted our invitation to share his first-hand experiences with the vision, mission, and technology behind evolution of the Mars exploration program. We are also anxious to learn about the latest results of these remote sensing efforts to better understand the fate of our less fortunate neighbor, the red planet Mars. Today's presentation is another unique opportunity to be reminded that in reality we are all astronauts because we are constantly traveling around the sun on a fragile spacecraft called planet Earth. Recent pandemic helped people become stronger believers in power of science to satisfy their physical and spiritual needs. That is why pioneers like Dr. Naderi play a major role in bringing us together and enhance our global connectedness to recognize and protect our shared destiny. Fortunately, he doesn't need much introduction, and a brief bio of him was circulated with invitations. But a few highlights of his remarkable achievements are that Dr. Naderi has spent more than 36 years in various technical and senior executive positions at NASA. While best known for his leadership of the Mars exploration program, he has contributed to some of the most iconic NASA robotics missions to various corners of the solar system as a director of this exploration program. In March 2016, asteroid 1989 EL1 was renamed asteroid Naderi 5515. He is the second ethnic Persian with honorarium in the space after Omar Khayyam, famous Iranian mathematician and astronomer with an eponym on a moon impact crater. Dr. Naderi has also been very active in community health and has served on advisory board of a number of philanthropic organizations, including Encyclopedia Iranica. He is now devoting his vast intellectual resources to inspire and help new tech startups and young scientists, particularly Iranian scientists in diaspora. Please note that some of the participants have sent me a few questions in advance, which I will raise after Dr. Naderi's talk. And there are a few more questions can be raised through the column on the chat column of this Zoom platform. Without further ado, this is my distinct pleasure and honor to invite Dr. Firouz Naderi to start his presentation. Thank you.
Good evening, everyone. I'm not quite sure I can live up to the lofty introduction just given. Certainly, I'm not anywhere close to being in the same class as Khayyam. But I appreciate the introduction. Since we landed on Mars about 50 days ago with Perseverance, and in about 3 or 4 days, we're going to attempt at flying the first ever helicopter in another world. I thought this would be a good topic to discuss tonight, and I have basically going to talk to you about how do we go to Mars, and just a few brief slides on why do we go to Mars. So with that in mind, let's get started.
Dr. Naderi, excuse me.
Yeah.
Can I mute everyone in order not to bother your presentation, and then you just yourself unmute yourself? I want to mute everyone on this, and then you please unmute yourself.
Okay, I don't. All right, do you have me?
Yep.
All right, okay. So much like when you travel on Earth, when you want to go from point A to point B, your first thing to do is to pick a highway. You may do it because it's scenic. You may do it because it's fast. You may do it because it is safe. So same way, when we go to Mars, our first job is to pick a highway, so to speak, through space to go to Mars. The people who pick these highways for us are called in NASA mission designers. They basically try to find a way through the vast space to get you to Mars. So let's take a look at this chart. The blue circle that you see is the orbit of Earth around the sun. And the red circle that you see is orbit of Mars around the sun. So needless to say, if you want to go to Mars, somehow we need to get the spacecraft from the Earth's orbit to Mars orbit. And that is what is called trans-Mars orbit. So as Earth is going around the sun and Mars is going around the sun, every 26 months, they get reasonably close to each other, like 56 million kilometers. So your instinct might be the way to go to Mars is to wait when the two planets are very close and then sort of make a dash for it. And that, it turns out, is not the way to go to Mars, because as I said, the primary objective is fuel efficiency. Why? Because a rocket that lifts off from the Earth has certain capacity, which is divided between the payload, the spacecraft, and fuel. The more fuel you have to consume, the smaller the payload the spacecraft has to be. So in order to maximize, get the biggest spacecraft to Mars, you have to find out the most fuel efficient route to go to Mars. And as it turns out, that is a orbit sort of looking like the yellow orbit that you see that initiates on Earth and terminates on Mars. So what happens when you get to the Mars orbit? Well, it depends. If Mars is there to greet you, it will capture you. If it is not there at the same time that you reach Mars orbit, what happens with the spacecraft is that it just turns around and slides down and come back to Earth. So what is important is what's important is to make sure when we get the spacecraft to Mars, Mars in its orbit is there to greet it. And this happens every 26 months. And that window is only about 3 weeks. So let's say if you start 6 years ago building this spacecraft, this is not like some kind of a real estate contract that the contractor can be promising you a date and then be late 5 months, 6 months, 7 months. This, when you start, you need to target a 3-week window where you have to finish the job and you have to launch it. Managing a Mars program with this tight window, it's rather challenging. So it takes about 7 months for the spacecraft to reach from Earth's orbit to Mars orbit. And Mars that during the launch was close to Earth has moved in its orbit and rendezvous with the spacecraft, and the gravity of Mars gets a hold of the spacecraft and pulls it in. So the distance that you cover to get to Mars is something about a little bit less than half a billion kilometer, 470 million kilometers is that you have to travel to get to Mars, and it takes 7 months. Now, when finally the spacecraft is at Mars and Mars has captured it, of course, Earth has also moved in its orbit. And at the time of the encounter, the radio link from Mars to Earth, traveling at the speed of light, takes 11 minutes, which means as the events happen, and maybe you watch it on television from NASA and it says we just landed, the fact of the matter is that everything is 11 minutes later than when it actually happened. I can tell you personally that when we are in the control room that day, when we're landing, that last 11 minutes is the most excruciating time for the mission designers, because we know the spacecraft is now on Mars surface. Either it has crashed on Mars surface or it has soft landed on Mars, but we don't know. So it takes about 11 minutes for us to be fully informed. Now let's talk about how once we're launched, how do we get to Mars? The spacecraft is at the tip of the launch vehicle that you see on your right, and is basically composed of 2 components. One of them is a donut-shaped disc at the top. This is the cruise stage, which means after the launch vehicle has thrown you towards Mars, the spacecraft that makes sure that you stay on that yellow trajectory, that yellow orbit that we talked about before, it is the cruise stage that takes you, it sort of is the bus that carries the spacecraft to Mars. Now, its cargo is the entry capsule at the bottom. And entry capsule inside of it, very cleverly packed, is the rover that's going to be delivered to Mars. So let's now let's assume that we are now at Mars. By convention, 125 kilometers above the surface of Mars, by international convention, is considered to be Martian space. I mean, there is obviously no sign that says, you know, you're all welcome to Mars. But when you get to 125 kilometers, that is considered Martian space. And the entry capsule gets there traveling at 20,000 kilometers per hour. And 7 minutes later, one way or the other, it's going to be on the surface of Mars. Now, the engineers who worked the Mars program has affectionately, they call this 7 minutes of thrill and terror for reasons that you will see why in a minute. So the first thing that happens when the spacecraft, the entry capsule, is barreling through the atmosphere, even though the atmosphere of Mars is very thin, it is only 1% of the Earth. But nonetheless, when you're traveling at 125,000 kilometers per hour, it gets very hot in front of the spacecraft. In fact, it gets to be about 3,000 degrees Fahrenheit. And if you do not have a shield, you're gonna burn up. So what I'm going to do is, there is a 2-minute video that's going to show you how this 7 minutes of terror actually takes place. There is a bit of a noise in the background. I don't know whose microphones is open. Oh no, before we get that, let me unpack the entry capsule so that you can see all elements of it. Right at the top, number 1, that's the cruise stage, and 10 minutes to Mars, it will separate and go its way, and the capsule underneath gets to enter the Martian space. Number 2 and number 3 are the 2 parts of the entry capsule that come together and form an enclosure where inside of it is the rover. Number 2 is called the back shell. At the end of it, there is a parachute that at opportune time, it blows open. And then number 3 at the bottom is the heat shield that I told you about. So what is inside? Inside number 5 is the rover. That is what you're trying to get to Mars. But it also includes a jetpack that embraces the rover. And when you get to about 20 meters or so, it acts, we call it sky crane. It acts like a crane, lowering the rover to the surface. So this is all verbal description. Now, what I want to show you is a 2-minute video that basically does everything that I talked about. The cruise stage separated now, and the capsule is going to Martian atmosphere. It's about 3,000 degrees now, and the spacecraft experiences a lot of shakes. When you have slowed down enough, you open up the parachute, and you need to be very careful. If you open it too soon, it's going to rip. And if you're going to open it too late, there is not enough air left under it to slow down. So it has to be very precise. Now the heat shield is ejected. And this is the sky crane carrying the rover underneath. It lowers it on a piece of ropes and then cuts it, and the sky crane goes and crashes, and you have delivered, hopefully, a successful rover on the surface of Mars. About 100 or so things need to happen precisely at the exact time during that 7 minutes for the rover to get on a surface of Mars successfully. Now, okay, so you want to go to Mars, but Mars is a big planet. Where on Mars do you want to go? Let me reverse the order and give you an example. Assume an alien spacecraft is coming to Earth. And you ask it, where do you want to go? He says, well, I want to go to Earth. Okay, that's a big planet. I can get you to Earth, no problem. Where on Earth do you want to go? I want to go to Canada. Okay, Canada is also a big country, and I can deliver you to Canada. That's no problem. Well, I want to go to Ontario in Canada. All right, that's still a big target. We can deliver you to Ontario in Canada. Then you get more ambitious. Say, no, actually, I want to go to Toronto. Well, if you would have asked this 20 years ago, what we would have said is that, look, we don't have the technology to deliver you exactly to Toronto. We're going to deliver you to an area which we call the uncertainty ellipse, noted by the red ellipse on the map. We can promise you that we'll land you somewhere within that ellipse, but it may be in Toronto, and you may end up in Buffalo. And they say, well, wait a minute, I see some water. There is Lake Ontario there. Is there a chance that I would fall in the water? And the answer is, yeah, unfortunately, yes, we don't have technology better than that. So if you want to be safe and land exactly on land, you need to target maybe Ottawa, maybe you need to target Montreal, where the entire uncertainty circle, the ellipse, lands, covers on land. But then you said, well, I don't want to go to Ottawa. I want to go to Toronto. That's where I want to go. And this is always a fight between engineers and scientists on Mars. Engineers want to get you to where it is safe to land, and scientists want to go to where it's good science. There are good geological areas on Mars that you want to investigate. There is this back and forth between the engineers and scientists. Fortunately, we have improved our technology, as you will see. So let's say, back on an analogy on Earth, you get a bit more ambitious and you say, actually, you know what? I want to go to the corner of Yonge and Bloor, not only Toronto. Can you let me off at that corner? Well, still the answer is no. We're not that precise, but we can get you to Toronto within a few blocks of the corner of Yonge and Bloor. So with that analogy, basically the technology that we have going to Mars, we are now able to target the lander to land fairly close on a few blocks, let's say, worth in Toronto on Mars. So where do we want to go on Mars? Where the place that we want to go on Mars is a crater called Jezero Crater. And why do we want to go to Jezero crater? Because it is the site of ancient lake. And why are we interested in ancient lakes? Because if there was any sorts of ancient biology on Mars, chances are that even if it was microbial, that it would be where water was on the surface. So we have always been interested to go to Mars where previously, billions of years ago, we had standing water. But unfortunately, we always did not have the technology to go there. So let me get you closer. This is basically the blue circle shows you the crater on Mars. So another interesting thing here is you see on the upper left corner, something snaking towards this lake. And this is the riverbed of an ancient river that was draining into this lake. And then from Earth, we know when rivers drain into lakes, once they get to the lake, it's sort of spread out in something that is called river delta. So it's almost like your arm. As you proceed, you get to your wrist, and then how your wrist expands into the palms of your hand. That's the same thing that happens when a river ends up in a lake and forms a delta. And the interesting thing about delta is that if the river was carrying with it, the content of the river would be deposited at the delta, at the mouth of the lake. So in that area is where we want to send our rover to take a look at, see what was deposited by that river in this lake billions of years ago, and find out if in fact there was biology on Mars, whether life in addition to Earth also happened on Mars. Okay, so can we do that? I mean, that's still pretty tight spot. Can we land our rover that close to the delta for our investigation? Well, by the way, this is the delta, and you can see this is an image we have taken from orbit. The different colors are different minerals on and near that delta. Now, take a look at, see if we could have landed there 20 years ago when I was managing the program, and Spirit and Opportunity, if you may remember, were the two rovers that we landed. But at that time, the only place we could guarantee is this large dashed ellipse. As you can see, we would either undershoot or overshoot the crater altogether, let alone land anywhere close to the delta. So we could not, 20 years ago, target this site. We took Spirit and Opportunity to a flat land where we could land. Then 8 years later, in 2012, we landed Curiosity, a rover that looks like Perseverance, but it's totally, the instruments are totally different. Even that you can see, even though technology had improved, even the smaller orange ellipse still overshoots the crater. So, and we ended up sending Curiosity to a larger place.
No, this is a...
Okay, so what happened with the Perseverance, the one that we landed 50 days ago? We used the technology that could narrow that uncertainty circle to something like about 5 kilometer radius. And this is what allowed us to land so close to such an interesting, scientifically interesting site. And engineers were confident that they could deliver the rover perfectly to that area. Now, even that wasn't very easy. This is the same site. The white line is the direction of flight for the rover as it was coming in. And any place where it is red on this chart, it would have been end of mission. It's dangerous for the rover to land on any place which is red on this mission. And as you can see, it is dominated by that. So with this one, at the tail end of the mission, we are using a technology called terrain relative navigation, and that's the green part of the white line. And let me tell you what that is. You have heard, unfortunately, this is a war game, that missiles that target a particular building in Department of Defense, they normally have a image, a photograph of the target stored in their memory in the missile, which was deposited there before. And as the missiles gets closer and closer to the target, it starts picking up and imaging the target. And now it has two images, one which was stored in its memory and the other one that is taking in real time. And it adjusts its direction so that the two images exactly superimpose, and then they know they are headed in the right direction. But as you know, unfortunately, even then, things happen. They want to target a military base and they end up hitting a school nearby. So it is still not a perfect technology. But we use this technology, which is called terrain relative navigation, to deliver perseverance to a safe spot near the delta. And here's how we did. This is the real, in the actual, the blue teardrop that you see, that is exactly where Perseverance landed. And you can see it is very close to delta. Therefore, it doesn't have much to drive in order to start its investigation. And so that part was pretty successful. Now, what did we deliver? This is the rover, very impressive. It's the size of an SUV. It weighs a ton. And just to imagine, sometimes we take it, we don't allow it to sink in, that we take a 1-ton SUV, take it 500 million kilometers across the solar system, and land it safely within a few blocks of where we want to go. The more that you know about the intricacy of the task, really the more you are in awe of the accomplishment. So that is the outside of the rover. Inside, in the belly of the rover, you can see the complexity of the circuits and that is required to operate the rover on Mars. A little bit about the evolution. The little rover in the foreground, Sojourner, was the first vehicle to rove Mars. It's a little bit bigger than a breadbasket. And it landed in 1997. The one to the right is the model of Opportunity and Spirit, the two twin rovers that I had the good fortune of managing, being the program manager at the time. And that was in 2004. To the right is Curiosity, which from the outside, it looks like Perseverance. Perseverance is about 100 kilograms bigger, but from the outside, unless you know what to look for, they look the same. I know it by looking at the tires, because the threads on the tires for Curiosity and Perseverance are different. And so that is a vehicle. The thing that makes the rover a scientific laboratory are the instruments. And Curiosity and and the Perseverance have totally different sets of instruments. Let me introduce you. Now, let's first talk about why do we go? What's the objective? What's the scientific objective of Mars program? It is to answer 3 questions. Was the environment on Mars ever right for emergence of life? Okay, on Earth, obviously it was, and life emerged on Earth. Was it ever that way on Mars? And if it was, and by the way, if in fact the environment was right for emergence, did life in fact emerge? It's not a given that if the environment is right, you will necessarily develop life. So the second question is, if the environment was right, did life emerge? And finally, the last one, if life was on Mars, is it still there now? Of course, we know life isn't there like you and I, but the more that you know on how life emerged on Earth and the incredible set of things that need to happen for that to happen, if in fact in our little solar system, little tiny solar system, life emerged in 2 places, on Earth and on Mars, or maybe on Earth and Europa, a moon of Jupiter, the possibility that the universe is teeming with life exponentially goes up. Not only it happened on Earth, but in our solar system, in fact, happened in 2 places. So that is really the reason we are trying to figure out if, and I use this advisedly, I'm not using it in a religious sense, this miracle that happened on Earth with the emergence of life, did it happen elsewhere in the solar system? If you do not interpret miracle in a biblical sense, it really, the more that you know, and that's really a subject for another discussion. It would have been a 2-hour talk if I would have included that in this talk of how life emerged on Earth. It really is somewhat a miracle. Okay, so what have we taken with us to be able to determine whether there was life on Mars or not? So there are, I've highlighted some of the instruments. Number 1 is a X-ray spectrometer that emits X-ray, and it is to analyze elemental at the size of sub-millimeter scale. Number 2 is an ultraviolet spectrometer, and it emits ultraviolets and detects organics, which are absolutely needed for life. Number 3 is a corer, and I'll tell you why we core. You core into the rock and take samples, and as I will explain in the next couple of charts, those are samples that we're going to try to bring back to Earth. Number 4, MOXIE is a very interesting instrument. As you know, the atmosphere on Mars is carbon dioxide, is not fit for breathing. We need oxygen. But we are going to try to experiment. Can we take carbon dioxide, which is CO2, and take the oxygen away from the sea and get pure oxygen? And if you have pure oxygen, of course, you can use it for breathing. You can combine it later with H to get you water. And you can also use it for fuel to fly back from Mars to Earth. But this is a subscale model that we are going to try to find out whether the technology of converting on Mars works. Number 5 is a subsurface radar. Number 6 is a weather station. It tells you about the temperature day and night, about whether the wind is blowing and all of that. Number 7 is a laser which we zap rocks with and powderize rocks and then analyze from afar with a spectrometer what the constituent of the rock was. That's SuperCam. And then number 8, you can see some of the cameras. They were all together 23 cameras that we have on Perseverance. I thought this was interesting. I just included it. This picture to the left came down from Mars yesterday. And the picture to the left is in the lab when we were assembling Perseverance. I know that the engineers who work on these things, and they know at one time they touched this thing, they wired it, they tested it, and to see something that they handled for months and months, then all of a sudden on the surface of Mars is a special thrill for our engineers. Okay, so what are we going to do with Perseverance? We eventually want to bring samples of Mars back to Earth. Every time we have gone to Mars, it's in all one way. We have never come back from Mars, right? And so to bring samples back, you have to get the technology to lift off from the surface of Mars and bring samples back. And that is so complex that we have divided it into 3 separate missions. So it takes 3 missions to bring samples of Martian soils back to Earth. Perseverance is the first leg of the 3. What it does, uses its instruments in the delta to select promising samples, uses the corer to sample the soil out of delta, and puts it in a little test tubes. You see 2 of them on the surface here in the lower left, and it leaves them on the surface there. And there are 40 of them. So it fills 40 of these capsules and leaves them on the surface. Then a second mission we send probably in about 4 or 5 years. And what we would do with that second mission, we send a smaller rover to go pick up the samples and puts them inside a spherical container, which is the size of a soccer ball. And for the first time ever, we're going to launch off the surface of Mars. And the payload is that sphere with all the samples inside. But in order to get it off the Martian surface, is not powerful enough to bring the samples back. So what it would do, it will take the sphere and puts it in an orbit around Mars, lifts it off the surface and puts it in an orbit around Mars. This is the second mission. Now we go to the third mission. A third mission is a spacecraft that's going to go to Mars. In the vastness of the space around Mars, is going to spot this little sphere, the size of a soccer ball, rendezvous with it, capture it, and then cocoon it in a protective surface to make sure that we're not bringing anything back from Mars that's unhealthy for humans. So anything that has touched the surface of Mars would be cocooned inside the spacecraft before it is brought back to Earth. And why do we do that? You know, we're sending all this state-of-the-art instrument to Mars, but there's still not a match for what you can find in the University of Toronto, in UCLA, in Stanford, in the laboratories, vast laboratories that are in our universities. We cannot send those to Mars. It cannot be duplicated. So we send miniaturized version of those. And of course, as you miniaturize, you lose accuracy and precision. But it is hopefully good enough to bring intelligent samples back to Earth, which then we will distribute to the scientists so that using their vast resources, be able to say, you know, what do we see? Okay, I'm getting to the last part of my talk. In addition to the, in addition to perseverance, we are actually also experimenting with a small helicopter, a drone, about 2 kilogram drones that we are sending to Mars. And if successful, I think it's gonna attempt its first flight in about 3 or 4 days. This would be the first time ever humans have flown anything on a alien world. Okay, so why do we need helicopter? So in many cases, in Mars, we really want to dig kilometers deep in the surface of Mars to find out the layers below, but you cannot. You know, there is, you know, we cannot take a excavation truck with us to Mars. But fortunately, nature has done the job for us. Like there are so many craters on Mars where there has been a impact from a foreign body and has dug a piece of Mars out, and therefore you can go and take a look at the walls of these craters. And much like, if you're familiar with, I'm getting a mental block here. The
Grand Canyon.
Grand Canyon, thank you very much. If you go take a look at Grand Canyon and take a look at the layers of Grand Canyon, it tells you exactly what was happening in that spot, you know, thousands and maybe millions of years ago. And therefore, the crater walls in on Mars also will teach you, but the rovers can't go there. But an aerial platform can fly and image and do spectroscopy on walls of the craters. That's one use of it. And so we are experimenting. We have not, we're not sure that we can fly a helicopter. And why not? Because Mars's atmosphere is 1/100th of the Earth. Is there enough air to get a lift, to lift the helicopter up in the air? We think so. We have done our best to equip this little guy with the technology that we think can even fly in the atmosphere of Mars. For scale, this is what it looks like relative to its mother carrier. And it was attached to the underbelly of the rover when we launched it. So here it is on Earth. The rover is belly up, and you can see that we have neatly folded. And I'm at awe of our mechanical engineers on how they fold hardware, and then how on Mars they unfold hardware. So here it is in the laboratory. This image now, you can see the rover lifted, and underneath it, you can see the rover. So in the next image, this is now on Mars. We had protected the rover by an enclosure. A few days ago, we dropped the enclosure so that the rover is now exposed. And a few days ago, we deployed the rover, all 4 legs, and now it is sitting on the surface of Mars. Very critical is that so long that it was attached to the rover, we could keep it warm. Right now on Mars at night, it can get to -100 centigrade and -100 centigrade. And so the rover needs to keep himself warm when it does not have the protection of the spacecraft, of the rover. And so as soon as we dropped it, the rover drove away, exposing the solar arrays on top of the helicopter so it can charge the batteries inside the the helicopter so it can keep it warm. So that step has also taken place. Okay.
Have you ever been blocked? Your horizon hidden? Ever wanted a partner to help get off the ground? Overcome hurdles. Discover what lies ahead. Scan the possibilities. Find the next waypoint. And return home. Ready for the adventure of a lifetime. Mars Helicopter. Join us on the journey to Mars.
That, of course, was animation, and we're hoping to actually do this thing for real in a few days. I have an interesting story to tell you, and that is that in order for these missions to happen, not only you need to solve technological problems, you need to come up with the money. When we started the helicopter, we thought it was going to cost $40 million, and NASA wasn't sure that that was a good investment, wasn't going to give us the money. So at the beginning, I thought of Jeff Bezos of Amazon. And as you know, Jeff wants to deliver packages to doorsteps using drones. And I thought maybe we can convince him, just as a marketing campaign, to come up with $40 million that for him was a drop in his vast ocean of wealth. But at the end, that didn't happen, and NASA gave us the money. And by the way, the helicopter cost $80 million, and it is now on the surface of Mars. We will see if that was a good investment. All right, I want to finish up with the 2 slides, because every time I give this talk, the question is why are we spending all this money when we're dealing with pandemic, when you have medical diseases such as cancer that we need to eradicate? There is homelessness on Earth, there is world hunger, there is environmental issue, and many other ones. So where do we get the money for these? When we waste our money, people argue, going to Mars. Well, I have a suggestion where you should get your money to make sure that these social issues are addressed. Let's take a look at the US federal budget for last year. It was $4.8 trillion. Out of that, $2.74 trillion is spoken for already. It's a mandatory Social Security, Medicare, and all of that the government has committed. They have no option but to spend it. Okay, so that much of it is gone. Then there is, because all the time the government exceeds their available budget, they have to borrow. So every year they have to pay interest on a debt that they have accumulated. Last year it was $345 billion. So that leaves roughly $1.5 trillion for everything else, everything that we talked about, right? Okay, so let's dig into, because that's the only available budget, let's dig into that and see what are the components of that. All right, roughly 40%, not quite half of it, is spent on the defense budget. I know you cannot read the graph, so let me read it for you. The US spends more on the defense than the next 7 nations combined, which includes Germany, England, Russia, France, India, Saudi Arabia, and China. Do we really need to spend as much as the next 7 countries combined? So what about NASA budget? NASA budget is annually $22.6 billion, which is less than 0.5% of the US annual budget. So should we address pandemic and cancer and homelessness and infrastructure? Absolutely. I would say spend 99.5% of our budget on those. But then for what we gain in terms of science and in terms of technology, which advances us as a civilization, would it be too much to spend 0.5% of the budget? And if you, in fact, are needing more for a pandemic, I'll know a reservoir of money to go to, a defense budget. It doesn't need to be 7 times as much as the next 7 countries combined. All right, so that's getting a little bit of my frustration out. I apologize for that. All right, and I'm wrapping up right now. I have only 2 slides left. This is fresh. It came out yesterday or today. It's a selfie taken by Perseverance on the surface of Mars. And you can see Ingenuity sitting on the ground not too far away from it. And the Ingenuity took the camera in the end of the arm that I showed you before to take this selfie. And so my last chart is to just give you a sense of history and how we have come along. It was 117 years ago when in North Carolina, in Kitty Hawk, the Wright brothers flew the first plane, 117 years ago. What you see at the bottom picture, we were given a small postage stamp size of the cloth that was used in that plane, and engineers are taking it along for a ride. They are putting it underneath of the solar panel on the helicopter, and it is now gone to Mars. And if in fact it flies, if we are successful in flying the helicopter in 4 or 5 days, okay, that you can see how far we have come in 117 years, from that to the jumbo jets, to the shuttle, to helicopter on another planet. So who's to say everything right now seems impossible? Who's to say what's going to happen in 117 years, next 117 years? And in the history of mankind, 500 years is nothing. 500 years ago is when the North America, the Americas were discovered by Europeans 500 years ago. So what about another 500 years? Where will we be? And that is why you do not want to stop the progress of science and technology, because it is dragging along the civilization with it to places and things that we cannot even imagine now. So with that in mind, I think I'm going to stop. And if you have any questions that I'm able to answer, I will be happy to answer. So I will stop sharing my my laptop and be ready for your questions if you have any.
Okay. Thank you very much indeed, Dr. Naderi. Such a eloquent and also elaborate messages on the advancement of technology these days that we all enjoy more or less, even not immediately. In long run, you consider it as the mother of all technology when you go to space with such accuracy. Of course, it's going to advance all sides of engineering and other science related to that. So this is a blessing, and I'm very glad that at the end you brought up the question of budgeting and philosophical view on the priorities of humankind, where to put the money and which ideals or goals to pursue. Given that, there are a few questions that you already answered through your very nice and elaborate and detailed presentation. One of the few remaining ones which I received in advance, which I'm going to raise it, and then we are going to take some questions from the audience through the chat page. One of them is that you mentioned that difficulty of going because they're too far distances, and it takes months or years to get to the destination. Is there any fuel technology in horizon to get us there faster?
No, and unfortunately, that is the biggest technology challenges that we are yet to overcome. I'll give you an example of interstellar travel. Let's say between the solar system and the nearest star to us, which is 4 light years away from us. If we go at 10% speed of light, which we're not anywhere close to it, it would take 40 years to go from Earth to the very closest star. I'll give you another analogy so that you can see how far away we are from that kind of technology. In 1970s, in mid-70s, we launched a spacecraft called Voyager. And it is now screaming away from Earth. It has left the influence of the sun, and it's going away at about 70,000 kilometers per hour. 70,000 kilometers per hour. Every hour, it's getting further from us. At that speed, it's going to take around 80,000 years for us to get to the closest star to us. So I hate to be doom and gloom here on the propulsion technology. You can improve it some, but you still would get to a fraction of light travel. And as you know, the distance in the universe is all measured by light years in terms of distances. So I am not sure that anyone has even proposed on paper anything which would make a big dent in that technology yet.
Okay. Another specific question was with regard to the chances of finding subsurface water on Mars. Apparently, there has been sign of ancient water, but not on the surface. How deep do you think you can use your radar scan or other devices to go there to make sure that there are groundwater reservoirs on Mars?
Okay, so today is April 7th, and that happens to be a special date for me. It was 20 years ago on April 7th, 2000, that I was named Mars Program Manager after we had a couple of failures and NASA was looking to revamp the program. A year later, on April 7th, 2001, we launched a satellite called Mars Odyssey, 2001 Mars Odyssey. And one of the first things that it did, by looking for abundance of hydrogen, it found out that in the poles of Mars, there are vast reservoirs of water ice. And by the way, today, April 7, 2021, is the 20th anniversary of that mission, which is still it's continuing. So we have not discovered, I wouldn't say that there isn't, but we have not yet discovered underwater liquid water. We have ice water, water in forms of ice, but we have not detected liquid water unequivocally. So the answer to that is still no.
Okay. So you touched upon the need to go into space and search for sign of life in other planets. But the main objective, other than scientific curiosity, I think it's because we are all vulnerable and our life and extinction is at stake on the planet Earth ultimately, whether by an asteroid or comet impact or by some sort of disasters or even wars, atomic wars or whatever. So do you think this is not the important objective enough to encourage getting more sort of budget or concentration on going out finding a refuge in other planets or somewhere in the space?
So I'll go back to what I said earlier, right? 500 years ago, Europeans could have said, you know, all that we need is here. Why do we need to go across the ocean? And at any rate, we don't know what's at the other side of the ocean. We may fall off the earth. And when they started, the Magellans and Columbus and everybody else tried to explore, they had no idea what they may find. And it is because of their curiosity that, you know, we know of continents, the Americas and Canadas and US and everything else. So first of all, as I said, who knows what happens in 500 years from now, right? So a lot of people say the money that you spend trying to go and terraform, which is a name for making Mars like Earth. Why don't you spend that money and don't destroy Earth? That is not the only two options. The question is not, do we destroy Earth or do we go look for a beachhead on Mars? Of course, we should not destroy Earth. That's even a silly notion to contemplate. So we are not going to Mars because we have decided that we're going to destroy the Earth. Of course, we should not do that. But for reasons that you cited, and for even other reasons, as the population of Earth explodes and the resources on Earth are limited, is it possible that we may have a colony on Mars 500 years from now? The same way that you and I are sitting on a continent that was not known to mankind 500 years ago? The answer is yes. And so now some people are ambitious, like Elon Musk, who, in addition to being really a technical genius, he is even better marketing genius. You know, for a while, he used to say he's going to land humans on Mars in 2018. Well, that didn't happen. And then now he says 23, 24. And he says, I want to have 1 million people on Mars by 2050. I think he is ambitious, but do I think there will come a time when we have 1 million people on Mars? I think so. But we should never talk about colonizing on Mars and letting go of the Earth, letting go of protecting the Earth. These are not the options. The options is to do that and expand our horizons both.
Right. Okay, my last question is that if you know that the immediate danger for humankind here on this planet is maybe impact of an asteroid or comet, like what wiped out dinosaurs. So the chances are that this could have this impact sooner or later. We don't know exactly. is that this technology has helped to identify the Apollos or these rocks which are crossing the orbit with Earth and could possibly impact and could prevent them or redirect them somehow?
Yes, I'm happy to announce that asteroid Naderi is not a Earth-crossing asteroid, so it will never impact Earth. So, yeah, so that's clear. But so NASA has tasked where I used to work, Jet Propulsion Laboratory, JPL, with a asteroid tracking. And so the first thing that we have done, we have identified about 1,000 or so asteroids, which are 10 kilometers. These are the size that wiped out the dinosaurs on Earth. Okay, and we can track their orbit precisely. Not only now, we can track them to 200-300 years ahead of time. The position tracking of NASA is remarkably accurate. And right now, there is nothing that is headed to Earth in the next 100 years that we should worry about that is, let's say, a few hundred meters and can cause damage. So we are all the time, if NASA's budget for this thing is, I believe, $20 million a year. We are tracking more and more asteroids. We're identifying them. We are determining their sizes, and we're determining their orbits. So we are developing a catalog to have our eyes on this. And also there is a technology that if we know something is coming our way, and we know it years in advance, let's say 7-8 years in advance. And as I said, our orbital mechanics are such that we can predict that. There are some ideas, if we intercept it early enough, can we deflect it by 1 millimeter or 2 when it is 10 years away? And if we can do that, it's gonna miss the Earth by kilometers. So they're also looking at technologies for the deflection of asteroids.
Very good. Thank you very much again. It was very inspiring for all of us and me in particular. And before just opening up the chat room for other questions, just want to remind everyone that Dr. Naderi was born in Shiraz, and no wonder that he is not only a top-notch scientist and engineer, but he has got a philosophical visions. Maybe if he's so humble, he doesn't want to compare himself with Sadi and Hafiz, but I'm sure he has got inheritance from that beautiful weather of Shiraz and the flowers and drinking the Rukna about water. So give him such a broad vision about the life on this planet. And thank you very much again.
As you retire to your dinner table, let me also tell you that wine about 7,000 years ago came from Shiraz. So if you enjoy a glass of wine tonight with your dinner, that's the origin.
Very good. Yeah, I remember the pleasure of in Granite Club having wine with you and enjoyed it tremendously. Can I ask Dr. Hossein Nejad to raise the questions
on the chat?
On the chat, please go ahead.
Yeah. Okay, thank you so much, dear Dr. Naderi. I have some question here, then I can read from that one. Okay, the first one, some guys actually said, I have a question about the Phobos and possibility of using it as a transportation hub for delivery of the material and equipment to Mars. Is it possible to use the moon?
Yes, in fact, the last thing that I did before I retired from Mars, from JPL, is that with 2 other friends of us, we came up with an architecture of traveling first to Phobos because it has, smaller and has small gravity and doesn't take much to push away from Phobos to come back to Earth. And so one of the ideas is, yes, to first travel as a dress rehearsal, is to go to Phobos, anchor there, because it doesn't have much gravity. If you're not very careful, the astronauts can shoot up into the space, and they have to be anchored down to Phobos. And then, so for humans, since it takes about 3 years round trip to go to Mars and come back, and you may say, why 7 years? Why 3 years? Because I said it takes 7 months to go to Mars with robots, is because when you want to come back, you have to wait another 26 months for the alignment of the planets to be such that you can come back. So when you add it all together, it's a 3-year journey. For humans, aside from technology, we have not yet determined the biological harm that may come to astronauts. So I've always talked about going to Mars has 4 challenges. One of them is money, one of them is technology, one of them is biological challenges of protecting astronauts, and the last one is psychological challenge, getting astronauts together in a confined environment for 3 years. You know, we haven't tried that yet. So that also is a problem. But the short answer to your question is yes, definitely Phobos can be used as a staging ground.
Okay, thank you. The second one is there an agricultural project at NASA that crop physiologists or plant scientists can work with in the form of the postdoctorate or research in the Canada or USA?
Not in a big scale. I know that in space station, recently they raised radishes, torokche.
Okay.
We didn't have abgush, but we had torokche. And so yes, they grew radishes, but it has not yet, you know, in a big scale. Certainly, we haven't even thought about how you would do that on Mars. But yes, they have started the growing agriculture in space.
Okay. The second one is a very short question, I think, about your presentation. He asked, is the 11 minutes always remain constant? I think you talk about the 11 minutes for any.
Yes, in fact, you know, not every time that we go to Mars, you know, the geometry is the same, but roughly at the encounter, at the time where the orbiter, where the spacecraft is being captured by Mars, it's roughly 10, 11 minutes, between 8 and 11 minutes. But of course, it doesn't stay there because Earth is rotating, and you know, later on, it could be much, much longer, and you know, as much as 20 some odd minutes. So I'm only talking about the instant of capture.
Okay, great. Okay, next, the UAE recently placed a probe in the Mars orbit. How much of this achievement is due to UAE own technical capability, and how much of it was farmed out? Who did the real technical work on the project?
Okay, I have, you know, I have a presence on Instagram, and many of our compatriots in Iran were trashing UAE that, you know, with their money, they buy everything. I'm not as harsh at all, right? So it turns out that this year, when they launched, it was the 50th anniversary of UAE as a nation. And they targeted to have a spacecraft going to Mars. They built a institute, an agency in UAE. They started developing engineers, aerospace engineers. The spacecraft that went, in fact, was built in America. It was built by University of Colorado. But it was then shipped to UAE, where it was tested before it was sent to Japan, where it was launched. So UAE, you may know, that has only the population of 1 million. It's 10 million people live there, but 1 million are from UAE and 9 million of immigrants. For a population of 1 million to have the foresight to do something, I mean, they could build, you know, another Burj, whatever, but they spend their money that way, and they are using it to educate and inspire their next generation of students. So I'm not at all harsh on UAE. I think it was tremendous that they did this. But did they build it in UAE? No, they didn't. Will they someday build it? Possible.
Okay, thank you. Okay. Another question, there are still so many mysterious in the moon planet to be discovered. Why NASA not focusing on the moon planet than Mars?
Okay, so if the question is the moon, or they're talking about our moon, right? So yes, we are focusing on that. In fact, the ex-president of the US, I will not mention his name, you know who I'm talking about. He wanted to have astronauts, he wanted to have a Kennedy moment when Kennedy said in the 60s, we're gonna, you know, land on Mars by the end of the 60s. He wanted to have that kind of a moment. So he charged NASA with landing astronauts back on the moon by 2024, which he thought would be the end of his second term in office, which didn't happen. So there is a program to go back to the moon, but this time is to establish a base station and be able to use it possibly for commerce and maybe even tourism. So this is as far as the moon is concerned. But also there are moons around other planets. For example, Saturn and Jupiter, each one of them, we have one moon. They have 60 some odd moons. And some of those moons, specifically Europa, which is a moon of Jupiter, has a very high potential of harboring biology. So there are also missions that are planned to go to Europa, and not our moon, but the moon of Jupiter, to look for life.
Okay, thank you. And another question is, the part being separated, what happened to that? I think when you...
Yeah, the sky crane. The sky crane, after it delivered the rover, it flies away and crashes to the surface 1 or 2 kilometers away in a safe distance. People have asked me, well, couldn't we reuse it? No, not cost effectively, no.
Okay. Okay, next is it true that the spacecraft is sent toward the Mercury or Venus first to circle around and gain future velocity and then target toward Mars?
So for Mars, we don't need to do that. You know, we have sufficient energy to go directly from Earth to Mars. But for example, I told you about Europa, a moon of Jupiter. We right now, today, we do not have a rocket powerful enough to go directly to Jupiter. So the last one that we sent, called Juno, what it did, we sent it halfway to Jupiter, and then we turned it around and brought it back to Earth, to near Earth. And as it skimmed the Earth, it picked up some energy from Earth and went out again. For a second time, we brought it back to Earth and picked up more energy yet. And finally, it went to Jupiter. So this is called gravity assist, and it is used for outer planets. For Mars, we don't need to use gravity assist, but for Saturn and further out, we need to. Or we need to build a humongous rocket that can do it in one shot.
Okay, thank you. Okay, we have several questions. I don't know, do you have a time or?
I can do another 3 or 4 questions.
Okay, thank you. Okay, the next question is, can this experiment in any shape or form cause damage to the Mars environment?
Well, one thing that we do on any destination that there is a potential for biology, either past or present. The last thing that you want to do is to take some kind of bacteria with yourselves to Mars, and then your instrument discovering it and saying, oh, wow, look, we found life on Mars. So for this reason, we, a big budget of any mission is to completely clean the spacecraft. Where we can, we bake it. We put it inside a chamber with a high temperature. We bake it so that any biology perishes. And then also we physically do alcohol wipe. But yes, there is a concern. Particularly, it's not so much for the moon because there is no biological potential on the moon. But when you go to a planet or destination where there is a potential, you have to be, there is a international treaty that you have to observe before you go.
Okay, thank you. Do you control rover from Earth, or everything is programmed in rover and it be done automatically?
Okay, more and more now, our rovers are getting smart, but our rovers keep bankers hours. They wake up in the morning and late in the afternoon, they go to sleep and they don't do anything. And during that time is when our engineers on Earth, when there is night on Mars, based on the data that was transmitted by the rover during the day, Martian day, they plan the events of the next day and they relay it up to the rover so that when it wakes up in the morning, it has a brand set of instructions. But whereas we used to allow the rover to just take baby steps without our permission, now maybe it can drive 100 or 200 meters autonomously without us interfering.
Okay. 2 more questions, I think. Could you share more about Elon Musk program about the life in the Mars?
So Elon, as I said, really a genius, a technical genius, just looking at how many diverse businesses he has succeeded in. He is fanatic about Mars, and he's spending quite a bit of his own money, to do that. And now, after Tesla, he has a lot of money to be able to do that. I think his targets are a bit too ambitious and unrealistic, but I have no doubt that he will achieve it one day. And he has a partnership with NASA. So I think between NASA, SpaceX partnership, and then also there is Jeff Bezos and his Blue Origin company. So there is right now, it's not like the 60s when it was either NASA does it or nobody else can, right? Now you can have a NASA private sector partnership. And so, yes, I mean, Elon is doing great.
Okay, last one. Do we have a sample of the Mars soil or lab now, and have we tested and analyzed it now? Is there an idea how much is it bearing capacity?
I didn't hear the last one. Nearing what?
The capacity, bearing capacity. B-E-A-R-I-N-G capacity. I don't know what it means. How much?
I don't understand that question, but the first
capacity, maybe
bearing capacity is the resistance of the soil or rock to get loads. so the amount of load that it can bear. Is that what he meant?
That's right. That's the question that I asked. Correct.
Yes. Okay.
Okay, thank you.
Okay, I'm not a geologist, so that your last question, unfortunately, I cannot answer. But your first question is that is the reason we send the Perseverance to sample, because we have not brought any samples of Mars to Earth yet, right? So the Martian soil would be sampled by Perseverance, and a second mission will go in 4 or 5 years, lift the samples off the surface of Mars into orbit, and a third mission will bring it back to be analyzed in the laboratories. I'm sorry, I cannot answer your third question. If it is in any way related to geology, I'm not a geologist, so I cannot properly answer that.
Maybe Dr. Mohajir later can answer the question. Okay, there is also a few, I don't know, we can continue, we can finish.
I think we should appreciate the time that Dr. Naderi allocated to this communication. If he's, I think he's tired because he said 2-3 questions. So we would like to ask Mr. Mohajir, the current president of Mohandes, to say farewell to everyone, and in particular, thank Dr. Naderi again.
Thank you so much, Dr. Naderi.
Yes. Dr. Firouz Naderi, on behalf of the Board of Directors of Mohandes and collaborations of several associations, including Tehran University Engineer School graduate, Sharif University, Tabriz, and Petroleum University, and Shenakh Association, to take this opportunity to express my gratitude for your wonderful presentation today. Your many years of research and in-depth understanding of Mars was very evident in the presentation. It was very insightful and inspiring. We are proud of you, and we wish to see you again in Mohandes. Your name will have a place in the long stretch of history. And a few words in Farsi. آقای دکتر نادری، من به عنوان یک ایرانی نام شما را در کنار حافظ و سعدی شیراز در قلب خودم به عنوان یک انسان خادم بشریت حفظ خواهم کرد. سپاسگزار و درود فراوان به شما.
خیلی ممنون. Let me also finish in Farsi then. Well, let me do it in English, maybe it's easier. Many of you have taught before, and you know that there is a connection between the speaker and the audience. When you're standing on a platform and you're looking into the eyes of the audience, you have a sense of the room, and you can better present and pace yourself. I have now done several Zoom lectures. Unfortunately, it is not as effective as it is when you're in a hallway and talking to people. You know, I lose my concentration when I'm just staring at the laptop as opposed to, you know, addressing a room full of people. But, you know, we are where we are with the pandemic. I'd like to thank you for your invitation. And I hope a little bit of what I said you found interesting and informative. And with that, I thank you. And I think I will now leave the meeting and bid you all a good night.
Thank you.
Thank you, Firouz.
Thank you. Appreciate it. Very much appreciate.
کامنت ها که خوب بودش. کامنت هایی که ما خوندیم در پارتیسیپانت ها الحمدلله همه راضی بودن حدودا. و تبریک به کانون مهندسی و سایر گروه هایی که پارتیسیپیت کردن. از همه متشکرم.
یک گروه بسیار زیادی امروز آمدن آقای دکتر و از شما هم تشکر که در واقع خیلی کمک کردید و اصلا شما باعث بودید که آقای نادری تو به اصطلاح آمدن و برای ما صحبت کردن. از طرف انجمن تشکر میکنم.
منم اگه اجازه داشته باشم از طرف انجمن دانشگاه صنعتی شریف خواستم تشکر کنم از همه دوستان و بورد کانون برای این سخنرانی ارزشمند. متشکرم.
با طرف قانونی یا با قانون مهندس
من با وجود دوستان از این فرصت استفاده میکنم از طرف شناخت از کانون مهندس، آقای مهندس مهاجر عزیز، آقای دکتر مهاجر عزیز، آقای مهندس محقق عزیز و سایر دوستان واقعا ارزشمند تشکر فراوان دارم. بسیار جلسه خوبی بود و من سپاسگزاریم رو مجدد اعلام میکنم. خیلی ممنون.
اگر اجازه بدین منم از جانب تیرگان به عنوان کسی که در خدمت ایشون تو تیرگانم بودم بخوام تشکر کنم از پرزنتیشن بسیار جالبی که دادن. من شخصا کلی مطلب یاد گرفتم.
خواهش می‌کنم اینجا فرصت استفاده کنم و ضمن تشکر از همه دوستان که تشریف آوردن علاقه نشون دادن. ما باید از این جلسات بیشتر داشته باشیم برای که این اتفاق و همبستگی ماها رو بیشتر میکنه. به عنوان کامیونیتی ایرانی خارج از ایران که گفتم ما قبل از اینکه جلسه شروع شه با آقای نادری صحبت میکردیم که ما مفاخر ملیمون و اسطوره‌های تاریخیمون همیشه باعث ارتباط ما بوده. یعنی از طریق همین حافظ و سعدی و خیام و فردوسی و اینا دور هم جمع می‌شدیم و لذت می‌بردیم از حضور هم دیگه و بعد هم یه اتحاد به وجود میاد. حالا اینا باید یه کمی دامنش رو فراتر ببریم، تو مسائل علمی و فنی رو بیشتر گسترش بدیم. اگر دوست دارین آقایون پیشنهاد بدین که این جلسات حالا کانون مهندسی یا فراگیرتر بشه و همه انجمن‌ها شرکت کنن و سخنران بیارن و مسائل فنی رو مطرح کنن.
ببخشید من میتونم یه سوال بپرسم؟ سلام دوستان، من نرگس هستم. برای اولین بار تو این کانون توی این حساب حضور یافتم و اینها و واقعا باعث خوشحالی منه. فقط من یک سوالی دارم آقای دکتر مهاجر، میخواستم ببینم به عنوان حالا هممون بالاخره مهندس معمار هستیم، حالا دکترا داریم، تو این شرایط داریم کار میکنیم. میخوام ببینم که تو بحث آرکیتکت این اسپیس آیا مثلا شما میتونین راهنمایی یا مثلا ریسورسی رو در اختیار ما بذارید که مثلا الان من میدونم یک سری کمپانی ها حالا توی امریکا توی امارات دارن روی یک سری پروژه های ناسا کار میکنن از لحاظ به حساب پیش طراحی برای ناسا. خواستم ببینم توی این زمینه چه اطلاعاتی میتونین در اختیار ما بذارید.
بعد خودم شخصا چیزی در این زمینه نمیدونم، ولی اگر شما برای کانون بفرستید، کانون مهندسی، ما اینا رو میتونیم ریدایرکت بکنیم یا حواله بدیم یا خواهش کنیم که آقای دکتر نادری یا سایر ایرانی هایی که در این زمینه کار میکنن بتونن کمک کنن. اتفاقا یه خانم ایرانی هستن در ناسا اخیراً جز تاپ انجینیرها هستن به اسم خانم بهار، حالا من اینو اسمش الان تو ذهنم نیست ولی در میارم. خانم بهار اربابی و اردهی. ایشون خانم خیلی جوونی هستن که قبلا توی کانادا بودن، از مونترال رفتن، الان یه چند سالی در ناسا. اصلا ایشون دیزاینر همین هلیکوپتری که نشون دادن آقای دکتر نادری، دیزاینرش و سازندش خانم ایرانی هستن اینجا. به هر حال اگر شما در تماس باشید با کانون، از اون طریق میتونیم شما رو معرفی کنیم یا اونا رو معرفی کنیم بشن.
من ایمیل فرستادم به کانون ولی خب هنوز فعلا جوابی دریافت نکردم و ممنون میشم. حالا اگر یک ایمیلی هستش که بتونم من حالمو بپرسم ممنون میشم.
اگر mahajer@rogers.com یا آقای محقق، جناب محقق رئیس کانون هستند.
اگر تحت نام من بنویسید kanun@mahandes.com attention my name.
امکانش هست، عذرخواهی میکنم، امکانش هست تو چت باکس بنویسین شما اینو اگه براتون امکان داره. مرسی.
حتما.
مرسی.
آقای عزیزی امکان داره
اسم این دختر خانم جوان جزمین مقبلی هست. جزمین مقبلی. در ناسا.
آقای دکتر مهاجر، اون خانومی که فرمودید بهار پرتوی، این اسپیس آرشیتکت ناسا هست.
بله.
بهار پرتوی.
بله بسیار خوب.
این اسپیس آرشیتکت ناسا هست. من فکر میکنم خانم سبزیواری درسته؟
نرگس هستم. نرگس بله.
ببخشید. به هر حال اینو چیز هست، بهار پرتوی، اگر گوگلش کنید خودش اسپیس آرشیتکته در ناسا.
خیلی عالی. خیلی خیلی ممنونم.
متشکرم. با اون اگه مستقیما در تماس باشید احتمال خیلی خیلی کمکتون میکنه.
بله متشکرم.
ببخشید اگه صدای من رو دارید، من از کلگری شرکت کردم به صورت اتفاقی. یکی از دوستان این رو برای من فوروارد کرد. میخواستم بدونم از کلگری شما هیچ روشی هست که ما بتونیم با انجمن شما در تماس باشیم و نه تنها فقط کلگری، بقیه جای به اصطلاح کانادا مخصوصا ونکوور خب مهندسین زیادی دارن کار میکنن و با توجه به اینکه توی اونتاریو و تورنتو مرکزیت در هر صورت از لحاظ تجاری، از لحاظ اهمیت اونجا هستش، اگر ما بتونیم یه جوری به انجمن خودمون رو ارتباط بدیم و از این وبینارهایی که شما میذارید اطلاع داشته باشیم و شرکت کنیم، ممنون میشم.
اگر لطف کنید برای ما به ما یه ایمیل ادرسی تو همون چت نوشته آقای عزیزی بفرستید، ما شما رو در ایمیل لیست قرار میدیم و این وبینارها رو شما براتون چیز میکنیم، دعوتنامه میفرستیم.
ممنون. حتما من به اون ایمیلی که فوروارد شده برمیگردم و به اوریجینیتورش پاسخ میدم که ما رو اضافه کنم. خیلی ممنون.
آقای مهندس محقق جسارتاً ببخشید، من یه بار خواهش کنم از دوستانی که عضو نیستن میتونن به وبسایت مهندس www.mohandes.com مراجعه کنن. اونجا اطلاعات کاملی داریم از ایونت هامون، از افرادمون، از اعضامون، از چجوری عضو بشید، بنفیتاش چیه و خیلی چیزای دیگه. یه دوری بزنید، دوباره تکرار میکنم www.mohandes.com، اونجا اطلاعات خوبی میتونید بگیرید. مرسی.
عالی بود. خیلی ممنون.
ممنون از همگی. شب همگی بخیر. خیلی برنامه عالی بود. دستتون درد نکنه. شبتون بخیر.
آقای مهندس محقق ممکنه برای انتخابات هم اعلام بفرمایید ماه آینده دوستان اگر مایل باشن برای
آقای مهندس عزیزی به عنوان مسئول انتخابات شما بفرمایید.
مرسی از لطفتون. والا ایمیلش رو برای اعضا فرستادیم که همه در جریان باشن. طبیعتا این ایمیل دعوتنامه برای AGM هست که در تاریخ 4 می برگزار خواهد شد. در این AGM ببخشید
5 می یا 4 می؟
5 می ببخشید شک کردم. 5 یا 4 می روز چهارشنبه. الان چکش میکنم، کانفرم میکنم. در اون روز AGM اول گزارش هیئت مدیره 33 ارائه خواهد شد و بعد طبیعتاً گزارش‌های مالی و بعد تصویب اونها. بعد جلسه رو واگذار میکنیم به هیئت مدیران که اونجا تشکیل میشه و جلسه رو میگیرن. عرضم حضور شما که یکی دو تا موشن داریم برای بازنگری اساسنامه قانون که اونو به رأی میذاریم. لیست این اصلاحات ایمیل شده برای دوستان، میتونن تکرار اونا رو ریویو بکنن برای اون روز آماده باشن برای رأی گیری. و بعدش گروه هیئت مدیره 33 وظیفهش تمام میشه و انشالله هیئت مدیره بعدی خواهد داشت. رأی گیری اعضای جدید برای هیئت مدیره طبیعتاً چون ویرچوال شده دیگه اون به روش حضوری نیست که تو همون جلسه ما رأی گیری رو انجام بدیم، اعضای جدید مشخص بشن و اعلام بشن. یه بازه فکر میکنم 3 روزه گذاشتیم بابت این که داوطلبی رو قبلا اعلام میکنیم تا روز 15 دعوت میکنم از دوستانی که علاقمند هستن به کار والنتیری و به اینکه به کانون مهندس و همکاران کمک بکنن رجیستر بکنن خودشونو. ما این لیست اعضا رو داوطلبین رو هم توی وبسایت میذاریم، هم به وسیله ایمیل برای اعضا میفرستیم که قبلا مطالعه کنن. بعد یه لینک رأیگیری از طریق یه شرکتی میذاریم که این شرکت ثالث کناری هست استخدام شده برای اینکه این رأیگیری رو انجام بده. رأیگیری انجام خواهد شد توی بازه 3 روزه و بعد نتیجه رو اعلام میکنن که دوستان جدیدی که مایل هستن به هیئت مدیره 34 ملحق بشن کیا هستن و افتخار میدن، کمک میکنن و بعد دیگه میریم برای بورد 34. در خدمتتون هستم اگر بازم مسئله دارید، سوالی هست.
من میخوام یه چیز اضافه کنم از دوستان عزیزی که ممکنه اولین بار باشه. این قانون مهندس 33 سالی که داره به اصطلاح در چه گفت قدیمی ترین جمع ایرانی در شاید بشه نمیشه گفت آمریکای شمالی ولی در کاناداست و ما البته به جز فعالیت‌های به اصطلاح سمینارهای مختلفی که هر ماهه و تقریبا هر هفته در کمیسیون‌های مختلف داریم، بحثنامه‌ای هم داریم که هر 3 ماه یه بار منتشر میشه. دوستان اگر بخوان مقاله چیز داشته باشن که علاقه داشته باشن چاپ بشه میتونن بفرستن و ما خیلی خوشحال خواهیم بود. در ضمن لازم نیست که حتما به اصطلاح عضو باشید، شما با همون مهندس.com اگه ارتباط برقرار کنید میتونید تمام فعالیت‌های ما رو در طول هفته و ماه داشته باشید، چون ما به اصطلاح گروه‌های مختلف تخصصی داریم، از مکانیک، برق، کامپیوتر، ارزم سیویل، اینا هر هفته سمینارهای مختلفی دارن و دوستان عزیزی که تو این رشته‌ها در واقع تجربه‌ای دارن، علاقه‌ای دارن میتونن تو این وبینارهایی که اصطلاح ما داریم و اجرا میشه شرکت کنن و خب هم میتونیم از اصطلاح دانش اونها استفاده کنیم، هم ممکنه چیزی باشه که به درد اونها بخوره. خیلی متشکرم. آقای محقق مثل این که خداحافظی
کنم که میتونیم آقای عزیزی دیگه جلسه رو با دوستان خداحافظی کنیم و براشون اوقات خوشی رو آرزو میکنیم.
مرسی.
خیلی ممنون از خانم. ممنون. روزتون بخیر.
ممنون از
خیلی خیلی برنامه عالی بود.
مرسی از همه دوستان، خیلی برنامه خوبی بود. تشکر.
متشکرم. شب همگی بخیر.
ممنون. متشکرم.